Have you seen AWS? A little bit? Or you did? No one? So we can do a couple of things there. We prepared a couple of presentations. We are going to talk about DynamoDB, which is comparable to the Sunback. It will probably take about 45 minutes to an hour. We can do a long introduction or longish introduction on AWS, say an hour, hour and a half, and then the DynamoDB presentation. I can take 45 minutes and race through AWS, then do Dynamo, and then do give an example on how we do MongoDB on AWS. So it's a little bit up to you. If you want to have like an hour and a half AWS, then DynamoDB, and then beer, or as much as possible. Beer, as much as possible. That's mandatory.
Probably there's not much knowledge about Amazon, yes?
No.
Probably
Introduction. We'll take most time then for AWS. And this is the right presentation. What do you think of our logo? It's brand new. If you go to the site, you don't see this. It looks horrible. So it is. You are. It's a premiere. We are 9apps. We are a small company. We call ourselves an AWS boutique. So we do special things on AWS. We wrote a couple of books. This is I took a screen capture with Elastic Beanstalk on top, which is not the most interesting book, I think. That one is behind. The second one is called Resilience and Reliability on AWS. This is going to be released in December. And the one at the back is the book that we wrote first, is called Programming Amazon EC2. The first part of the evening that I'm going to do is basically what's in that book. We earn our money with the companies at the bottom. We do their infrastructural part of their application, and we work in partnerships. So we are not a traditional consultancy company. We have a long-term partnership, and we have a limited number of slots. That's also why we have 9apps. Yeah, we have two applications that we sell on the iPhone and on Android, called Dika, with which you can manage your service. You can switch off your instances. This is the product page of AWS. I don't think you will be scared by this, because you probably have a product page just as long or longer, or all sorts of things like this. But if you show this to people, they are really overwhelmed. This is already a little bit older, so I think there are already things not on here. I don't see DynamoDB, for example. So they keep coming. Well, one of the things that you told us last time that you visited us, or from the presentation, I had the impression that you can, or that you see Amazon and Azure, you see them competing all the time. That they are stealing services and ideas, and they look at prices, and they make sure that they have the same prices, and they are really going head to head. Really interesting to see. So this is what, most of the things is what we work with. I am not going to go over everything. Things like DevPay, for example, and AWS import-export are things that I won't cover. But we will do a lot. A little bit of history. in 2002 they started to become what we now know as AWS. And the first thing that they released was S2S. In 2002 they came out with APIs to start selling your own books and selling your own stuff, but they went a step deeper in their services idea. So the first thing that they released was S2S. So that they had this big monolithic application. They were selling books and all sorts of other things, and it was unmanageable. And the first thing they needed to start taking the thing apart, so to decouple it into distinct applications, was S2S. So in 2004 they released S2S. Yeah, I assume that you know, but do you know S2S?
I think what we can
S2S is simple queue service. So it's a service which is a queue. You can store unlimited amounts of messages up to a message size of 64K. It is really unlimited, but you can your message can stay up to 2 weeks in the queue. After that, it sort of expires. Then they so no, it's okay. Good afternoon. There's a pleasure. Then they went on to their, so they started using this, they started decoupling their things, and they went on to the next big problem in most web applications of this size, but also a bit smaller, and that is storage. So they introduced S3. S3 is the same as blob storage. So it's probably exactly the same. Then after that, they came out with EC2, compute. Is there an equivalent for S2S in your sure? Storage queues. Okay. Are you familiar with these terms? Good. Then it appears that they did nothing in 2008, but I think they did a lot of things. But in 2009, they came out with SimpleDB, ELB, and RDS. ELB is the load balancer. SimpleDB is kind of a NoSQL service thing for table storage. This is easy. 50 minutes, we're done. And RDS is relational database service. That is basically Oracle, MySQL, SQL Server as well. That's it. And then, well, then they started adding more and more services on top of the things that they did. The interesting thing is that it is very cheap to start, doesn't cost very much, and it scales. So what we always talk about is that with the introduction of IaaS, with let's say AWS or with Azure, the thing that you gain is flexibility. So before you had your IT department, and you had to make a purchase order for servers, and it took a long time. You needed to go to meetings, and you needed to do a lot of work to buy an infrastructure, to set it up, to maintain it. So it was not flexible at all. It was one of the things that was most difficult. What you have now is flexibility. So you can start something, doesn't work, you can tear it down. If it works very well, you can scale it up. You can change it easily. So it takes a different position in your development cycle. So infrastructure now is not part of your IT operations anymore. It becomes part of your development team. And you can start working with that. It takes a lot of time, we see, to get used to that idea, because it is different from traditional administration. It becomes development. Well, this is the. I think this is the most interesting thing, consequence of this introduction of computing. It is a bit of a it's a little bit of it's a lot of text, but what you see is that what they do at Amazon is they basically make the development team responsible for operations, so they get to deal with customers. It's a bit scary. I think it is. I think if you take these chances, you are so close to the experience that your customers have, is that you improve much faster. And if you also take operations into it, then you have no divides anymore, and it is just better for the quality of your application. So the smallest infrastructure that you can have for kind of a web application is this. You have S3 for storage. You have RDS as for a database, most of the time MySQL. And you have EC2 for compute, and on top of that you have CloudFront. What's the equivalent of CloudFront?
I'm not entirely sure. I think it's a traffic manager. It's a discussion.
It's kind of an Akamai, kind of a content distribution.
It's called CDN.
CDN, okay. And this is enough to have a small application running. For RDS and EC2, you can now run micro instances, which is about $10 to $15 a month. S3 you pay per use, CloudFront you pay per use. This works. If you set it up correctly, then if it fails, you are back up again in a matter of minutes. So this is not a high available way of doing everything. Shall we go into the details of what's behind EC2 and volumes and snapshots and things like that? Is that a good idea?
Yeah, that's right.
Okay. Can you help me with the equipment, with the equipment on that you have in the shirt? EC2 instance comes in certain types. The smallest is micro, which is kind of a fair use policy type instance. You have 780 megabytes of RAM, more or less, and your CPU is you can burst, but once you reach a certain limit, if you burst too long, then you get throttled. So if you have small peaks, it's fine, but if you have a continuous utilization over whatever, then you get throttled down to 5% or something. The default, one size bigger is small, that is the default instance type. It has 1.7 gig one CPU. On top of that you have high CPU medium, which is 4 cores, 2 whatever, but it is more CPU, the same amount of memory. And you have a relatively new medium, which is high mem medium, which is 3.4 gigs of memory, and CPU power is in between the high CPU, medium and small. We use these three a lot. We hardly use micro because it is unpredictable what happens. We always use small or one of the two mediums. That's compute. There is something they call listed bookstore. Is there any equivalent for that?
Yeah, it's also part of your storage.
Okay.
It's called files.
Right. Okay. You can create the volume. You can attach the volume to an instance, to one instance, and you have something that's in between network attached storage or storage area network. It's also a little bit comparable to the RAID. It's not as fast as a local disk, but it is pretty okay. You can have them in sizes from 1 gig to 1 terabyte. And there's a very interesting feature that is that you can make point-in-time snapshots. So you can say, I want a snapshot now, and when your API call returns, you know that your snapshot is basically taken. It needs time to finish it off, but you know that you have a snapshot from exactly that point in time. We use that a lot. We use it for backups, we use it for the way we do databases, restores, and it's a really interesting feature. Do you have that in Root Drive? The same. Okay, sorry. Let me think. You can choose between 2 different sets of networking styles. One is the normal one that we most of the time use, and one is called VPC, Virtual Private Cloud. You can basically extend your local network with your Amazon infrastructure. So you have one network. It used to be more or less that you have the same kinds of features in both of these types of infrastructure, but you start to see differences now. In VPC, you can have an internal load balancer, for example, something that we don't have in normal or in say the regular infrastructure topology style.
You have public load ones, not internal.
And there is one open source.
Yeah,
Not any service.
Did you take a look at the console? Did you ever see that? No? I can show you an instance.
Yeah.
It's not so fancy as I figured, I think. Yeah. It's very fancy.
Yeah, it's probably more or less the same, except it's not so fancy. It's just for we work in this thing every day, and frankly, it sucks. It is not made for like day-to-day use. But you see here we have a list. We have 35 instances. Some of them are stopped. I think this is all pretty familiar if you work with Azure.
You don't use any other external management tools?
Yeah.
Or mistakes.
Yeah.
It's a little top window bar thing from the Mac. You can easily access it. Or see the CPU usage. Or maybe.
If you have an instance underlying an instance is an image, what's the equivalent of an image? An image. We make lots and lots of images, so we have our own naming thing. That's also one of the things that is not a strong point in AWS, that you need to have these kinds of ways to find your way into your own system.
You don't have properties or something to it, and you only have a name. So
We don't know. Very often.
But this is all more or less the same. If you look at RDS, then RDS comes also in types, but they're called classes. which I don't know why, but they started using a different term. You have micro, which is pretty convenient. You didn't have that for a long time. So you have micro, small, not medium, but large, and then you go up to, and the biggest one is for RDS is 68 gigs of memory and I don't know how many processors.
That's a real machine, it's not a...
No, it's
a real reaction.
yeah, it's okay. You can have, I will get back to that a bit later, but RDS you can have in something they call multi-availability zone. What that is, I will explain later. So you basically have a secondary running there, you can't access, and if your primary fails, then it does a failover automatically. So it is twice, it is two machines, so twice the amount of money, but you have a real, very good, high-grade commercial database system. Backups and lots of leaks.
Are you in charge of managing it, or is it done for you?
The failover?
No, the machines.
Yeah, it is done for you. But then, yeah. But with this, this is something that is new to them as well, because they provide like more of a service. Before they like with EC2 with compute, they really provide assets or resources, and if the resource breaks, it's your responsibility to get yourself a new resource. With RDS, they started providing a service, so with the RDS break, if you have multi-availability zone, RDS high availability database, if it breaks, they take charge of the failover. And sometimes it doesn't work. So if it doesn't work, what do? You contact the one providing you the service. But that particular part is very difficult with them. So you need premium support, which costs you a little bit of money, but it's money to help them debug their beta services. So that's not, there's something going, there's something that is not really okay there. I don't know if you have an equivalent for that as well, but that's
We have SQL Azure as a kernel service. I think it might even be more as a service, because we don't really choose machines. We just say we want a database of that size. We don't really know what kind of machines to choose.
okay.
But we also have the experience of the start charging stuff that's in beta.
It's supposed to work.
Yeah. But SQL Azure is not one of the.
It's
pretty still.
okay. S3, I don't know if the S3 has a kind of a reliability number of 79s, 99.999. I think there are 49s in total. So this is extremely reliable. It's also a bit expensive. They introduced something they called reduced redundancy S3, which has only 7 nines or 5 nines or whatever, and the chance of a file being corrupted or losing a file is a bit big, but you pay less. So if you have, for example, if you generate PDFs that you can regenerate later, you can store those PDFs on reduced redundancy S3. When it breaks, you get notified and you can regenerate. They introduced a storage service a couple of months ago called Glacier. And Glacier is like tape drives with a robot taking the tape out and putting it there. That is ridiculously cheap. I don't know, one cent per 1 gigabyte. It's really very cheap. Last week they also introduced a way to automatically offload S3 or archive S3 objects to Glacier. So then we are almost full circle. If you want to retrieve something from Glacier, it takes up to 4 hours or something like that. CloudFront, CDN. We will later get a pretty recent picture of all the stuff they have all over the world. But they have they're starting to be really competitive to services like Akamai. They're really starting to have a global coverage. Difficult continents were, for example, Latin America. They start to have a presence there. I know that Akamai is pretty strong in China, but Amazon is not. I don't know if Azure is.
There is a CDN node in Brazil. I don't think there is one in China. There's one close to China.
Singapore, Japan.
This is an old image. But later I will try to find a new image. Environment. You have your account, you have your console, you saw that, and you have command line tools. You have command line tools as well. And you have other tools like, for example, Recap, that you have right scale that you can use. You have management tools that you can use on top of AWS. It used to be that the command line tools were the console was really lagging behind the command line tools. There were certain things that you couldn't do in the console. That is getting better, but still command line tools have everything, and the console does not have everything. I don't know if that's for Azure the same, but
there's a lot in the portal.
yeah.
Sometimes you have to search a little bit.
Yes.
You can do more with the command.
Yeah. I don't know. You once you register, you are being called back, and they check all sorts of things. But it's pretty automatic. It doesn't take a long time. It takes a couple of minutes, and then basically when your credit card is accepted, then you can really start. You start your environment with a basic set of limits. For example, you can have only 20 instances running at first, and you really can't start more than that. Then you, if you do, they get notified and they send you a mail. Or if you know that you want more in advance, you can send them a mail, or you can fill it out the form to request more. The account that I logged into in the console just now, that is where we had one weekend. We ran 1,600 instances, which is, at least for us, it's a lot. And then they also contacted us saying, hey, do you like autoscaling? One of the services that we will talk about later. So you see that they really know what is going on. They have some people in Europe, and they do know who to get to. They do pay attention what is being done in their system. But this image is not very recent. But I want to tell you about regions and availability zones. If you look at compute and services where you have like assets, they talk about regions. At this moment, I'm going to get the other presentation. This. At this time there are 3, 4, 5, 6, 7. There are 8 regions. The most recently introduced is Sydney, a week ago, 2 weeks ago. There is one in Singapore, one in the other one in Asia, Tokyo. There's one in Europe, in Ireland. There is one in Brazil. There are 3 in the United States. The region has a couple of, at least 2 physically distinct co-locations, we call it like that, or data centers. The data center or a physically distinct data center is what they call an availability zone. So if they talk about SLA, they talk about SLA in these terms. They say we guarantee 99.something% of the time that there is an instance available in at least one availability zone. So there you see that is your room to maneuver. You can't rely on one instance in one availability zone. You need to work with availability zones. You can lose an entire availability zone. That is what they tell you. A region has at least two, but most of them by now have three or more. If you launch an instance, you can choose availability zone. So you choose EU West 1A, for example. EU West 1A for me is not the same as EU West 1A for Jasper. So they rotate the numbers or the names behind the availability zones to have some kind of load balancing probably.
If you tweet that zone A is down, that doesn't mean something means something.
They have another region, it's called the Gulf Cloud. You see in this image, you see a number of blue dots that are not part of the regions, and they are edge locations for CloudFront, CDN, or Route 53, the DNS service. And you see that there are more and more, or more locations than just the regions. Is there an equivalent for an availability zone?
Yes.
Availability zone, and for the region?
Yeah, we need to buy a data center basically. Western Europe, Northern Europe.
Okay.
For us, availability zone, we have actually we have a data center we work from. We also have updates. So these are called availability zones. So availability zones is actually hardware is automatically not checked.
Yeah.
And update the releases because actually Azure's platform as a service, so they update their stuff. They will ensure that no two instances are updated at the same time.
So die is altijd failover.
That's for storage. It's for the S3 equivalent. We have geo replication within regions.
So when we start working with the team of developers or with the company, we always have to choose the region for compute. We always try to choose them as close as possible to the user. But you can't always, because sometimes you want it outside of the US, basically. I saw that Azure has a banking, what was it?
Yeah, the Netherlands. Well, banking can use Azure.
The audits.
Yes,
Yeah.
so the official step.
Yeah, I talked with Bas about it.
Okay. Okay.
He was looking for well, I think it was not for banking. He's still working on it for banking.
Yeah.
It was for another it's government.
Government,
That's
That's what big news.
But they will have to do that case by case. It's not like if it works for one government, it works for the other one.
No, yeah.
Because
Sweden.
Sweden also does
Yeah.
the same thing.
So if you choose a region, you can get easily closer with CloudFront to solve all those other blue dots for your static content.
Paris and Amsterdam.
This is what we talked about. So The next step for, if you have that running, then the next step is to get your infrastructure elastic. So you want to scale automatically depending on your traffic. The top one is in AWS. If you want to scale instance types, you need to stop it. You need to stop your instance. It's not dynamic. So you can't dynamically add some CPU capacity, for example, or add some memory.
So we need to stop it or to tell you
Stop is enough. Oh, yeah, stop is enough. You have certain instance types that you can't stop. Okay, I think that is too much detail right now. The second example is by adding instances, and that you can do automatically. So they have a service called autoscaling, which is not part of the console, and we use it very often. We also use it for one instance, for example, because if the instance dies, then my autoscaling will take charge in getting me another instance. So you can have. I need to get to other services as well to explain this. In Amazon, you have something called CloudWatch. It's a monitoring service that has metrics on certain things happening in Amazon. Is there any equipment? Separate. You can have metrics. For example, an EC2 instance has metrics like CPU utilization, I/O network. So you see on a minute by minute averages, maxes or minuses, you see CPU utilization. If you have an auto-scaling group, you need to have triggers to say when to scale up or when to scale down. You can trigger those by pointing at a metric in CloudWatch. So if you have web traffic behind an ELB, for example, a very good measurement for when to autoscale a CPU, because you probably have it configured so that your traffic is handled nicely, and you see your CPU growing as your traffic grows, and you get to, I don't know, 30–40% depending on your stack. You add 2 instances, and then they start taking over some of the traffic. If you have more asynchronous type workloads, for example the PDF generation, you can put your tasks in SQS that we saw in the beginning, and then you can auto-scale on queue size. So in the case in the account that I showed, we have a lot of auto-scaling groups on different queues, and whenever the queue grows to 20,000, we add 2 more, and then if it goes to 0, then we move. One of the differences is that if you scale on CPU, you scale on a metric that comes from the instances in the autoscaling group. So you can never have an empty autoscaling group. If you scale on something external, for example queue size, or you can scale on anything that you put in CloudWatch, then you can have an autoscaling group of 0. With autoscaling groups, what you can do is you can say, I want minimum 2 instances, and I want my instances distributed over 2 availability zones. So if I add 2, I know that one goes to A and the other goes to B. So that way, when something bad happens and an availability zone breaks, something that happened about a month ago, then you have at least one availability zone. You can work to get to get extra capacity using a 3rd or 4th availability zone. But that is the way to achieve high availability. So you use availability zones. If an availability zone does not have the right capacity for what you request. So you request a high CPU medium in availability zone 1B, and it doesn't have it, then it will request one in one of your other availability zones. If later it becomes available again, it starts to rebalance. The problem, if you use this in conjunction with an elastic load balancer, that doesn't really work, because an elastic load balancer distributes the traffic evenly across availability zones, no matter what kind of instances are in your availability zone. Well, we had hundreds of instances in autoscaling groups, literally. So this it works also with bigger volumes. Do you have questions about this? Is there anything?
We don't have an equivalent for auto-scaling. It's not mentioned, but third-party vendors could do. Yeah, we have some. The main reason that we don't have it is because Microsoft says they cannot decide for us when to scale. So we have services that allow us to scale. They say you need to calculate for your specific business logic when you want to scale. And that's the reason why we will probably not have that scale.
Are there questions about this? It's the first thing that you don't have.
Not really that.
But
Yeah, we have a service called Azure Watch,
okay.
which is a third-party service. It's something that's not integrated.
Yeah.
But that does the same thing where you can pick their performance counters, and then you decide based on rules, like when it's over 80% CPU or whatever, you scale it.
Yes.
And it's not part of that.
Do you use it as your watch?
No.
No? No one uses it?
I don't.
Do you do it manually then? You know it's a busy day.
Yeah, either manually or we program ourselves something. We have a scaling API, we can scale, but we just don't have the rules to decide what is total. When we build something ourselves in our workflow, it's good.
Yeah. We experienced one big DDoS attack a while ago. And we learned that it's always good to be behind the load balancer and to be able to, how do you say, to buffer it, as I don't know, to work through it. It's like giving labor, sort of. So you scale up, and at least your service stays available. I pay more. Yeah, you pay more, but otherwise you're down.
Yeah, you even get an email from Amazon if they think there's doesn't they see traffic
But they don't say anything.
Do they protect you guys?
No. The thing is that they don't say it, so they don't promise it. So you don't buy it. So when they can't, you can't blame them. But I think that they have something like that, which I didn't have. They don't have. So I think so, but no. RDS is not auto-scalable. RDS, if you have a multi-availability zone, so you have like primary, secondary, you can scale that thing up or down within minutes. So you have you scale it up, you have a failover event, takes 2 or 3 minutes, and then you have a bigger database. If you're brave, you can do it automatically. We prefer to do it manually because it's a scary thing. But if you really have high traffic and you know it in advance, or you can scale up. You can scale up to the biggest for a couple of hours and you can scale down again. It works. this is what I said. One of the S3 is also organized in regions, and SQS is organized in regions. So if you work with this, pick your bucket close to your compute, because it takes a while otherwise. It is really very sluggish. If it's close, it is much better.
Do you pay for traffic between it?
Not if it's low. And I don't know exactly. Most of the time, your cost for traffic is minimal. So this is what it takes to scale an RDS. This is command line. And it's just that it's extremely easy. RDS has some other features that they have, for example, read cache. So you have your main database, and you can have a read, like a read-only slave. You can start up a number of them, I think 10 or something. So you can pretty easily move your read-only traffic to additional instances. They recently introduced the ability to promote a read-only or a read replica to a full RDS instance, which is convenient, for example, if you need to decouple your system. So you just run on your read replica, and then you can promote that read replica to the full RDS instance and then just keep a couple of tables. So that way it's easier to work with these big databases.
How does it work? Because Azure also has SQL services, like those feature organizations.
Yeah.
How does it work with the schema objects? Once you have X number of replicas, do they propagate schema changes?
That's part of
Do
it.
you have to?
No, it's in MySQL at least, it's a SQL command that is replicated. And if you do a promotion, you cut your ties. It's on its own. In the back, can you hear everything, by the way? Also when they talk. Oh, great. There is another service that we often use next to RDS, which is called Elastic Cache, basically memcached as a service. Do you have something like that? So if you have a relatively big infrastructure with auto-scaling, you need to do certain things for that. For example, if you have data on a volume that you need to keep because it's valuable to you, then you can't easily work with auto-scaling because you can only attach it to one instance. So that feature is not easily used anymore. You need to do some work, then you have your infrastructure which is elastic and it can do all sorts of things, but then it gets too big again. So what do? You use, you're going to decouple, and you can use for these things, you can use SQS, queuing, you can use SimpleDB, which is the database, simple database, or now DynamoDB, which Jasper will talk about, or SNS, simple notification service. Do you have an equivalent for that? It has topics, and you can subscribe to a topic. And you can subscribe with an endpoint or with a queue.
It's called
Service bus. Okay. Well, then you can start making multiple of these applications, little infrastructures to have one big thing like Amazon. That is basically what it did.
It can also email and SMS.
In the US, it can also SMS. Yeah, SQS is really great. We use it a lot. It is not 100% guaranteed that your messages retain their order. So you need to, if you really need 100% guarantee, you need to implement something like a counter yourself, something like an ordering. But most of the times you don't notice. And in most applications you don't need it.
This is a must-have. As a must-have only.
No. Also, that is like one fire project. We will get there. As I said, a queue in SQS has no limits on the number of messages it can contain. So it is a great buffer. If you decouple one of your components fails, and the other keep writing to SQS, just as long as if your other service is up again within 2 weeks and can process the items as well, you're fine. So it can really contain millions and millions and millions of messages. You can have many readers and writers. So you could, if you have like a mobile application with lots of users, you can have your mobile app directly push things to SQS. It's okay. So you don't need to scale for that kind of traffic anymore if you use a service like this. The message size is 64K. If it doesn't fit, put something in the street and refer to that.
Will you never be coupled on those kinds of queues?
No? They don't say. They say there is no limit.
The number of connections together.
There is probably a limit, but I don't know if that's what if you take CloudFront, for example, if you have like a soft limit in a number of like the size of your pipe, and for one edge location it's 10 gigabits or something. So it is yeah. If you breach that limit, it's still being served. Only you get notified later saying, hey, we saw that you reached the limit. Do you want to increase your?
Because we have the same in Azure, but we will be coupled for queues of about 2,000 connections per queue for an account, which is a container of queues. We'll be talking about 20,000. So if you plan to go over that, if let's say millions of clients, you have to plan to have multiple queues.
Okay.
And
I don't know. I think.
I can't imagine there's no limit.
No, there's probably
There's
a limit.
always a limit in these things.
You have a limit in the number of queues you can have, I think. And there's they say that it is not okay to keep your empty queues. They're not going to punish you, but it is not. They don't think it's very polite to do that. The limit is on the time that your messages can stay in the queue. And after that, they drop off.
Also the visibility, everything.
Yeah. If you it's like a two-phase commit. You take your message and then it's not being deleted. It becomes invisible. So you process. If you succeed, you delete it explicitly. I don't know if it's the same. SimpleDB. Jasper is going to talk about DynamoDB. He's going to talk about. We have an application that started for SimpleDB that we moved to DynamoDB. So I will
ignore this in the list.
SNS. Now we look at this as sort of the opposite of SQS. SQS is a buffer, so you can absorb things, and then so you don't accelerate your system. And SNS, it's a publish, subscribe message bus, and you can have many subscribers to one topic. It's an acceleration. So if you send one message, you can broadcast it to thousands of listeners, so it accelerates your system. So if you publish something internally, you need to understand that it has that effect. But it can explode your infrastructure if you don't realize the power access. But if you have SQS on the other side, it's okay, of course, because it can buffer.
This does not store the messages for us.
No, not at all.
Because in service bus we have two parts. One is the relay, which is the same as this. The other one is the broker, and there we actually have queues and topics which are durable. So it's basically, we have one queue in storage, which is the same as SQS.
Yeah.
We have another queue in service bus with slightly different characteristics and features. But I think this is the same as what we call relays.
Yeah. But this doesn't store anything. It goes through it's done. You can have different endpoints. SMS is only available in the US, which is a bit of a pity. We don't use it very often yet. I don't know why. We use SQS all the time, and this hardly. It's a bit weird. Yeah, to monitor if it really works, we use something outside of AWS. We use Pingdom a lot. Pingdom is pretty cheap. It is now better than a year ago, but still I don't trust it entirely. But yeah, I think everything else, all their competitors are way too expensive. Jasper will tell us about something that we have internally, but we need a couple of things more that Pingdom doesn't give us. We use before AWS, we also did infrastructures, and we used things like Nagios and Cacti, monitoring systems outside of your system, pulling your assets, pulling your compute, your instances all the time. You have nice graphs and things like that. We don't have the need for that anymore. We have a CloudWatch. I can show you that a little bit. So we have CloudWatch. CloudWatch shows you things like CPU, but also like storage, free storage space of your RDS. You have alarms. They have a lot of metrics that will take some time to load. You can add alarms. Alarms notify you through SMS. That's why we use it. So it sends a mail. But what it doesn't do is it doesn't measure things inside of your instance. So it doesn't know about your memory consumption, for example. It knows about your CPU utilization, but not about your memory consumption. So CloudWatch, we need one more thing to help us, and that's where we use. Let me show one. This is, for example, an ELB, and you can choose a period, and you can do all sorts of things. And this is pretty okay. You can also add your own metrics. So if you have Nginx, for example, you can take number of active connections, or if you have MongoDB, you can take. If you have a Mongo replica set, you can calculate the lag between the primary and secondary. You can put it in CloudWatch. You can be notified if it's above a certain threshold. So we use that, and the only other thing that we need is something on the instance to tell us if the disk is full, if the memory is over its limits, something that can help us kick processes what if they are misbehaving, and for that we use Monit. And we were looking for Monit on Windows, and they say no, but we use PRTG or something. Yes.
It's very fancy. This is everything with sensitive emails. It's like money.
So this is basically how we monitor. But there's one fundamental difference, is that if we find an instance misbehaving, we replace it. We don't care. So we don't need a lot of additional things. We just need to be, we just need to know that there are other instances available, and we need to have a predictable performance. And we can improve the performance, but we don't need to keep the points and run it all the time. So we don't need nagios, we don't need the cacti, we need more other instances if we want them. And we need to know that they always launch, they always perform more or less the same. And if they don't, they go away and we start using airline. This is just showed you this. But this is what it's this is like improving. That is what it's about. It's not like optimizing one thing. It's just getting a bit better every time. CloudWatch I showed already. But this is like, if you put everything together, you start using your multi-availability zones, then you have 2 instances or 3, so you span multiple availability zones. You have high available or multi-availability zone RDS, so that is the way that you expand your infrastructure. There, I briefly mentioned Route 53, which is the DNS service that they have. Is there an equivalent?
I think it's partially equivalent. We have traffic manager for performance service.
Yeah.
We have a little bit of DNS capability in infrastructure as a service. Maybe if you add those 2 together, you probably see it. Traffic manager is really DNS-based global load balancer.
Okay.
Can load balance you based on proximity or performance.
The Route 53 is, you can compare it to ultra-DNS. I always forget. You have 2 or 3 global DNS providers, which are pretty expensive, but it's a very it's a pretty vulnerable part of your infrastructure. It's vulnerable to DDoS if you use DNS from GoDaddy. You have experienced that a couple of weeks ago. They were DDoSed. DNS is gone, and you're gone. It's done. So we always use Route 53. It's a order of magnitude cheaper than anything else available. And
it's just it's like a regular DNS service when you can find prerequisites.
yes, exactly. But it has I don't know, but it has network level multicast stuff, all sorts of things to make it really fancy. But it works. It works. We do lots of things with the API, for example. So it's very easy to do a failover based on Route 53 if it works. So if you have a TTL, time to live, of 60 seconds, then you can manage your failover with this. Instead of like pointing different IP addresses, you can just point your DNS service. There's another service called Simple Email Service. This we also use all the time. So Amazon sends out your mail. If you begin working with it, you have to you say what you have to how to say you have to verify email addresses or domains to be able to send from and to. And then you can ask for production access, and then you can send to anything that you want. But you need to be able to send from verified domain or verified email address. by default you have already a pretty big capacity in volume sent. If you compare it, for example, to SendGrid, it is very, very cheap, but you have limited reporting capabilities. So you don't know a lot about what happens to your mails. You know it's sent, you might know that it bounced. We use it also for like monitoring this. It just works. There are two services, Beanstalk, which we wrote a little bit about a long time ago. They are way further now. Then you have something called CloudFormation. There in equipment. Okay.
I think these are application hosting.
Yeah, it's more like orchestration. Well, what Beanstalk does for you is it grabs all these services together and combines them in a way that you can upload your application and it gets pushed to instances behind the load balancer. That's basically what it does. And it started out as Java, and now it also does PHP and it does Ruby. So they orchestrate AWS assets into an infrastructure and they provide deployment interface.
That's basic.
Yeah.
It's one of the other concepts.
CloudFormation is how to describe it. You can basically script your assets. So what you could do is you can say, well, they have the notion of a stack, and they have the notion of a template. So they have a CloudFormation template describing your assets and the way that they are related. And if you launch the template, so you give it certain values, so for example, instance type, or a name, or well, all sorts of things, it takes that information and it starts, based on the description, it starts launching things for you. It can be an instance, it can be a load balancer, it can be an RDS, it can create bucket, S3 bucket, it can create CloudFront distribution, and then in the end it launches a stack. I think there are many people that expect this to be very big, because you can describe your infrastructure in a textual way. You can put it in source code control. So you can manage your infrastructures in time with source code control. That is a little bit. I don't think that's going to work very well. But what we use it for is for repetitive things. So we have one company we work with that does streaming events for big concert halls, and they have an event of an evening, and they need to launch two big machines with the CloudFront or the CloudFront distribution and a couple of other things. So they load the template, they fill in the name, and off it goes. And 15 minutes later, everything is ready, and then in the studio, they just have to point the encoder to the transcoder, and it starts distributing this thing. So, and then in the morning, they switch it off again. So for these kinds of things, it is it's ideal. If you have, for example, a very large development team or a large company, you can use CloudFormation if you want to spawn development stacks. So you can say, use this CloudFormation template to run this and this and this application environment, for example. Well, premium support, I briefly mentioned before, that's in Amazon land is very important. It's the only way to talk to someone in a way that you know you get a reply. So, and if you have a service that you rely on them to have it working, then you have to do this. And we tell them once a month that it sucks to have to pay for getting help on something that you buy from them. They don't want to understand that. Is there something like this in Azure? Premium support?
Yeah, there's a new school. Yeah. We changed model recently. I think we're going to this. In the past, you could simply get support.
So they go this way. Okay.
Yeah, they go this way.
Yeah, you get the types also. It's Delta type.
Yeah, you have developers like $50 a month or something, and then you have gold or whatever, or silver or bronze, and then you pay a minimum of 100 or 10% of your monthly bill, and you go to silver or platinum or whatever, you pay 500 a month or something like that. The irritating thing that I find very irritating is if you ask them a question, then they always start giving you advice on how to do things a certain way. No, I want you to answer my question. So if you get this model, I hope that you want to be better, because it's extremely annoying.
Now you have telephone support also.
Yeah.
Sometimes we call them and get the US number, but then they have some actions.
What I couldn't find, Microsoft does that better, is forums and stuff like that. Amazon people. Public forums.
Yeah. This for free, but you don't know when you but the time between the question and answer is limited.
How many times do you actually call people they contact you?
I did once this year, I think, for the RBS. Because then we were really tweets.
There are we had an outage a couple of weeks ago, which was pretty severe, and then we also, and then in that well, that's interesting to tell what happened probably. It was related to RDS, and they did a planned upgrade. And they notify everyone, they say, you have this RDS, is going to be upgraded between the 1st of November 2012 and the 29th of November 2012. Fine. During this planned upgrade, they made they introduced a bug in the failover. It was not only the failover, but they said it was the failover. But the problem was that when they point the host name or the endpoint, as it's called in RDS, to a different machine, then it appeared to work, but sometimes it resolved back to the old IP address. So you had a very weird pattern. So it worked, but sometimes it didn't. So, and we found out pretty quickly, and we said, now this is not okay. And we could remedy that locally, but it meant that we had to scale up. We had to switch off auto-scaling, and we had to set the private IP address with the RDS host name, the right one, in the host file. So if we had a failover, it wouldn't work anymore. So in that case, we talked to premium support. And we saw this in basically all our accounts. So all RDS instances had a planned upgrade that failed, and we had to talk to premium support. No, it was already paid. But still, it is very annoying. And exactly. And they said, each and every time they said, I'm sorry, we remedied your situation. This was an isolated event. Yeah, it's not. It's not an isolated event. So we are still trying to talk to Amazon to get them to acknowledge these kinds of things, because you can't work if you don't know what is going on. But for that you need premium support. You saw a lot of people in the forums complaining about the same. They say, I have this and it is because of that and that. Me too, me too, me too. And that's so basically isolated to this one. It was isolated.
It was already happened on there.
Yeah, that was 2 days.
Yeah. I think we covered everything. Are there questions?
do you exactly host things? Is it everything to check or services?
Yeah, everything. There are not many examples that we find that you can't do from a technical perspective. From a legal perspective, sometimes you can't, but we can't do very much about that. There's another situation is if the combination memory CPU, for example, is not what you want. Sometimes you want a very low CPU machine with a lot of memory. These kinds of things you can't do, but that doesn't happen very often. We did something in gaming once, and they said it was like a real life thing, and they said the latency needs to be low, and perhaps it doesn't work, but it was fine. And can you, there we talked with a company in Amsterdam that does this automated trading, trading of financial stuff. And there the game is to be as fast as possible. So they optimize their transactions in hardware almost. That's something that you can do. But for the rest, it's not. Most of the things are pretty easily moved.
So the latency, the closest, well, the nearest by data center is Dublin, or
for cloud stuff, we have Amsterdam, Paris, Madrid. That's a bit closer. It's pretty okay. You notice the difference between Ireland and the US if you work on your instances. The US is pretty okay, but if you go to Sydney, if you work on an instance in Sydney, or Tokyo was already pretty horrible, but Sydney is even worse. And you really notice the difference. Well, one thing that was always a little bit difficult was data warehousing kinds of applications, or databases, business intelligence, and we had. You can do a lot with EBS. So with the volumes, for example, we had Postgres running, and we scaled or we increased the performance capacity of the Postgres by using table spaces mapped to volumes. So because we have, I don't know if you know that, but you can put a table on its own table space, which maps to its own drive or its own mount point. So because we can make many volumes, we can have one instance with 24 volumes, or 20 megabytes or whatever, and we can distribute the read-write capacity over multiple volumes. And because it's like a RAID system, it's already a little bit better in these kinds of circumstances, but we can use 20 of these. So in a real physical environment, it's very difficult to get 20 RAID volumes, or to get 5 more RAID volumes for a couple of hours. It's just not easy to do. And they introduced something. They call. They introduced something called IOPS. So you can reserve a minimum amount, a guaranteed amount of I/O operations per second. So you can have your EBS volumes and say I want at least 1,000 I/O operations per second. Now they increased it to 2,000. So with these kinds of things, you have a predictable performance characteristics. You can have 20, it's a bit more expensive. So that was like a notoriously difficult area for Amazon, and they improved it.
It's always the thing they complain about on forums. Does actually have something like that?
That's the same problem. We don't have an area specific.